Folks, this is your agenda today. The first thing we're going to do is pass back the pre-quiz from yesterday, and if you didn't take the pre-quiz from yesterday, you're just going to get a blank quiz. You're going to watch this pre-quiz video and adjust your work as you go. I'm going to work out all of the problems. I'm going to explain them. Remember, this was a pre-quiz to see exactly how much you know. And so now I'm going to go over all of the questions. Adjust your work and your answers as you watch, because the third thing that you're going to do is return this quiz to the substitute so that we can update your grade in the grade book. So again, whatever your grade is on the pre-quiz, that's for your knowledge and for our knowledge, and you'll be able to get an adjusted grade in the grade book based on your adjustments that you make while you watch this video. After that, after you turn in your pre-quiz, again, we have a basic probability video for you to watch. I'm going to give you a couple places to pause during that video, and then you have a practice assignment. So by now you should have the basic probability pre-quiz passed back to you. I'm going to go through each of the questions. Number 1 says, a bed and breakfast offers a dinner that consists of one of 3 main courses, listed here, and one of 3 desserts, listed here. If the choices are equally popular, what is the probability that someone will order roast beef and pie? So these choices are equally popular, which means that the probability is the same for each of these choices. And we want the probability that someone orders roast beef and the probability that they order pie. So remember, basic probability means that you're creating a fraction. You want the amount of outcomes over the total amount of outcomes. So for roast beef, there's just one option in the main course, and that's 1 out of 1, 2, 3 choices. For pie, when you look at the desserts, there's apple pie, there's cherry pie, and there's chocolate cake. So there's 2 pie choices out of a total of 1, 2, 3 dessert choices. So when I think about roast beef and pie, does choosing roast beef affect my dessert choice? No, choosing roast beef doesn't have any effect on my dessert choice. So I ask myself, is this independent or dependent probability? Well, if roast beef has no effect on pie, then this is independent probability. So if we want the probability that someone is going to order roast beef and pie, I'm going to multiply those 2 numbers together. So you can do this in your calculator. 1/3 times 2/3 is going to end up giving you 2/9. If I were going to type this into my calculator, I would want to make sure that I use parentheses around my fractions. And remembering that in the calculator, this is a division symbol, so open my parentheses, 1 divided by 3, close my parentheses, and then I'm multiplying that by 2/3. So open the parentheses, 2 divided by 3, close my parentheses, I'm going to hit enter. Now 0.222 repeating is not an answer choice because my answer choices are all fractions, but I do want you to jot this down, that if you get a decimal and you go to the math button right here and you hit enter twice, so enter, enter, it will convert any decimal into a fraction. And so that way you can get your answer choice the way that they're presented here. So if you need a fraction, you can type your 0.222 repeating. You can get your answer, and you can type math, enter, enter, and you can get your simplified fraction. Let's move on to number 2. Number 2 says, if you take a number from this box without looking, what is the probability of drawing the number 9? So looking at the box, there's lots of different numbers. Remember that probability is finding the amount of successes over the total amount. So you're going to end up creating a fraction for the number 9. I need to count the number of 9s and put it here. I need to count the total amount of numbers and put it here. So for 9s, I see 1, 2, 3, 4, 5, 6. I see 6 9s. And then the total number of numbers that are in that box, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20. Perfect. So I've got my fraction. That's the probability of drawing a number 9. So it's the number of successes over the total possibility. So there are 6 9s and there's 20 total numbers that I could have drawn. Now, I can type this in to my calculator, 6 divided by 20, and I can get my decimal, which is 0.3. Now, unfortunately, that still isn't an answer choice here. And so if you remember from the past, previous math classes, if you're going from a decimal to a percent, what do you do with this decimal place? You move it over twice to the right. So instead of 0.3, you've got 30%, right? So 0.3 is really 30%. We took that decimal, we moved it once, twice to the right, filled in any spaces with a 0. So I look at my answer choices, and B is the correct answer. So when you convert from a decimal to a percentage, you move once, twice to the right. You can do the same thing converting from a percentage back to the decimal. You just move your decimal once, twice backwards to the left. Let's go to number 3. Number 3 says a spinner is divided into even sections. That's really important because that means that the probability of landing on each section is equal to the probability of landing on any other section. Everything is equally likely. What is the probability that the spinner lands on a dollar sign and flips a coin landing on heads? So we've got 2 events that are happening here. We have one event where they land on a dollar sign. We have another event where the coin lands on heads. So I've got dollar sign and H for landing on heads. Now think about spinning the spinner and flipping a coin. When you spin the spinner, depending on what it lands on, does that affect how the coin lands? No. Spinning a spinner and landing on something does not affect getting heads. So when I ask myself, is this independent or dependent probability, we'd say this is independent probability. These events are not affecting each other. Just like in the first question, picking roast beef and pie. They don't affect each other, so that's independent probability. So if I look at the dollar sign, looking at the dollar sign, I've got one here, one here. So I've got 2 dollar signs out of how many total sections, how many total possibilities? Well, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 possibilities. And then whenever I flip a coin, if I flip a coin, there are only 2 options for flipping this coin. It's either going to land on heads or it's going to land on tails. So there's only 1 heads on the coin, and there's either heads or tails, so there's 2 total options. So that creates our probability for heads. Now, if I want the probability of both of these things, and it's independent probability, I'm going to do the same thing I did on number 1, and I'm going to multiply. I'm going to get my calculator out, and I'm going to type in the fraction 2/12, 2 divided by 12, and I'm going to multiply that by 1/2, so in parentheses, 1 divided by 2. I'm going to get my answer. My answer is a decimal, so we've got 0.083, repeating, but it doesn't look like my answer choices. So what was the trick to be able to get this to look like a fraction? Hopefully you wrote it down. We've got math, enter, enter. And that gives me the fraction of 1/12, which is answer choice C. Okay, let's move on to number 4. Number 4 says, if the letters from the word geometry are each written on a piece of paper, so each letter gets its own piece of paper, and it's placed in a box, what is the probability of randomly drawing the letter E? So I need the number of E's over the total possibility of letters. So let's count the E's. I've got 1 E, 2 E's, 2 E's. Out of the total number of letters, so 1, 2, 3, 4, 5, 6, 7, 8, 2 out of 8. If you can simplify this without assistance, that's awesome. 2 out of 8 gives you 1 out of 4. But if you need the calculator, you know the trick now. You can type in 2 over 8, hit enter, and then math enter enter gives you the simplified fraction. Let's move on to number 5, so flip with me. Number 5 says a bag contains 7 orange balls and 4 purple balls. What is the probability of drawing 4 orange balls without replacement? Now, if I have 7 orange and 4 purple total, how many do you have? Well, you add those up and you get 11 total. 4 plus 7 is 11. Now, if I draw a ball out of this bag and I draw an orange ball, if I draw an orange ball, there were 7 orange balls, right? So I've got the first event, 7 orange out of a total of 11. But then I've got 4 that I'm drawing. So first event, second event, third event, fourth event. These are my drawings of a ball out of a bag, right? And it says that I am not replacing the ball that I drew. So if I drew an orange ball and I'm not replacing that ball, then does that affect the probability of the second drawing? Well, yeah, if I put the first ball in my pocket, then now there aren't 11 balls to pick from. There are how many? There are only 10 to choose from. And if there were 7 orange ones, and I put the one that I drew in my pocket, how many orange balls are there remaining? Well, there are 6. So this is not independent probability. This is dependent probability because our drawing on the first event affects the probability of the second event. So now there are only 6 out of 10. Well, how many are there on the third drawing? There are only 5, and it's out of 9 now because we put the second ball in our pocket. What about that fourth drawing? The probability of drawing an orange ball is now only 4 out of 8. So I'm going to multiply these probabilities together. I'm going to get some kind of fraction, some kind of decimal, but we know how to deal with that. We can hit math enter enter and we can get our simplified fraction, which will end up giving us 7 out of 66, which is answer choice D. Let's go to number 6. A spinner is divided into 10 numbered sections as shown. Assume the arrow never lands on a dividing line. So we're not talking about it landing on a dividing line. With only one spin, what is the probability that the arrow lands on a shaded section and points to an odd number? So this is shaded and even, shaded and even, shaded and even, shaded and even, shaded and even. So there are no shaded odd sections. That's 0 out of 10 total sections. And 0 divided by 10 is 0. Number 7, the bag has 6 red and 5 blue marbles. That's 11 total. We want the probability that they draw a red marble and then a blue marble and it's not replaced. So there's 6 red out of 11 total marbles. But then if you keep that first marble, there's 5 blue out of only 10 marbles. And you multiply those together, you end up with 3 out of 11. Number 8, Delilah rolled a die 360 times. Die just means one dice. So you have a pair of dice, but if you have a single one, it is called a die. So she rolled a die. The outcomes are here, 1s, 2s, 3s, 4s, 5s, and 6s. We want the experimental probability of rolling a 2 or a 3. Experimental probability means what happened in the experiment. She rolled 58 2s and 50 3s, and she rolled 360 total times. So if I add those up and divide by 360, I get 0.3, which is answer choice B. Number 9, the definition of independent means that events does not affect the outcome of another event. And then on number 10, the definition of probability is the quantified number between 0 and 1, where 0 indicates it's impossible and 1 indicates that it's a certainty. Think about weather. If it's definitely not going to rain, we say that there is 0% chance of it raining. If it's definitely going to rain, what percent chance is that? That's 100% chance. If I convert these to decimals and move the decimal back twice, we have any number between 0 and 1. The probability of it raining is anywhere from 0% to 100%, or anywhere from 0 to 1 probability-wise.